That's
Okay.
cool.
The first question is, what is the test? What is the test statistic? And I struggle with knowing which figure it is. Back in lesson 9, the test statistic was the z, but we're not using a z in these formulas. Is there a way to know which one it is?
Yeah, so the test statistic is used when the, I just want to say sigma, but when the standard deviation is unknown, and you need to solve for a value, or you need to solve for a z-score, but not the z-score, it's going to be a test statistic. But that's when you use that when the standard deviation is unknown for the problem. And so it's literally the same equation, just different variables are being used instead.
Okay. Okay. I'm just gonna have to keep working on that to make it gel.
Takes practice. I had to do this one twice. So.
Okay, so I guess
Cool.
get started with the first problem then.
Nope.
So it says, suppose that we have a set of paired data and let D equal x after minus x before. The null hypothesis is equal to 0 and the alternate hypothesis does not equal 0. And the population standard deviation is not known. Jordan collects a sample of size n equals 9 and computes D bar equal to 2.2 and S sub D equal to 3.3. What is the value of the test statistic? So from what was shown in this chapter, I did 3.3?
Yeah.
Yeah. I guess it'd be 2.2 minus 0 divided by 3.3 over the square root of 9. For me, I guess it came out to 2. I don't know if that would be correct or not, but I got 2.
That's what I got as well.
Okay. So it wasn't any of those numbers that they gave us. It's following that formula.
Yeah.
Okay.
Cool. All right. The probability of obtaining a test statistic greater than Jordan's test statistic is 0.0403. Use probability to determine the p-value of Jordan's hypothesis test. And I got 0.081.
And so how did you come up with that answer? This one I kind of didn't understand how to do.
So what I did was got the test statistic and then I put it into the probability applet, distribution applet.
So
and then I shaded to
probability
the
applet,
left.
Students T probability applet.
I did the students one.
Okay.
Let's see if I just want to double check and make sure.
Well, that's what I thought I did, but I didn't get your answer.
Just want to double check. Just this one. That worked for me last time.
You got?
I got 0.81. I got it right. Stromer time. Times that by 2. 616. Hi, Karen. So last time I just put it into the applet and it came out. Now it doesn't want to do it for me.
So the reason I didn't know how to use the applet was because it asks for the degrees of freedom, and we're not given that, are we?
No. We are not given
You
that.
have to solve for that, or because that plays a role in what the area under the curve is for any. You could put 2 in for the test statistic, but it'll change depending on the degrees of freedom. And so do we need to solve for the degrees of freedom somehow, or?
My applet came up with 3 in there, and I didn't even think to change it. Now that I've changed it, just messing around with it, it does change the number.
Yeah, but it'll only stay at 3. It won't change to 0 or anything. It'll just stay at 3.
Okay.
Yeah, I mean, you can put it at 1, 2, 5, 30, 50 until it becomes the normal probability curve. Because if I put it at 2, I mean, it puts it at 0.8165, but I'm sure
0.8165.
0.
When you put it at 2? Oh, I think you do. Okay, well, do you have to do the value of the statistic as 2 in the previous question?
I have the t value at -2 and 2. I don't have the degrees of freedom at. I didn't think that had to do with anything with the degrees of freedom.
I don't think it does.
Because I know, like, the quantitative or the paired sampling, one sample, t-test, and so forth, it solves for the degrees of freedom for you, but it's not like we have any values to use. Well, maybe we do. Let's see here. 2.2. The test statistic is 2. And our samples is 9. That wouldn't make any sense.
So we're trying to determine the p-value.
Yeah.
Right.
What's the equation for that?
For p-value?
Yeah, is there an equation?
Yeah, it's put into the applet. It should be where the number that's on the bottom, left or right of the area that's been shaded.
Okay, the degrees of freedom is n-1.
N-1?
Yeah. So in our case, it would be 8.
8.
But I don't know how that would give us. You say you got 0.081 or 0.81?
0.081.
Okay, so if you put in 8 on the student's T probabilities applet for the degrees of freedom, and the test statistic is equal to 2, when shading in, you always shade the outside, so you don't shade in the middle, you just shade the outside, and that'll get you 0.005.
Yeah. Then you have to round up to get 0.081.
Right.
Yeah.
So, but you get taking your number of samplings minus 1. So
N minus 1.
that's how you.
Okay.
Sample t-test. That's the next one.
That one's A.
One.
Are we still on 4 or moving on?
We can move on.
Unless you still have questions about number 4.
I can't get it to work in the applet, but
Did you shave both left and right, not the middle?
yeah.
And also, did you change your degrees of freedom to 8?
Yes.
So you got the.
Did you put the t-test as -2 on the left and 2 on the right?
No, I thought I was putting 0.0403 in the top.
No, well, I got the 2 from the previous question from the test statistic. So I put 2 in that way. Because it says use the following information for the next 2 questions.
Okay.
So I put because it says the T, so we had to compute the T.
Right.
So that's how we got the 2. So for this kind of applet, we need to find out what the test statistic is. So we put the test statistic, negative on the left side because it's less than 0, 2 on the other side, and then degrees of freedom, like what you said was n minus 1. So you put 8 in the applet, and it should pop up.
It'll be 0.805.
0.085, right? Or then.
So if you just multiply his number by 2, it's the answer. If you take the 0.0403, that's what's shaded after the greater, and then you need to shade the less, which is the same on both sides, the 0.0403. So if you just double that, it gives you 0.081.
Okay.
So this one, I guess it really does. It does. If you don't want to use the applet and just use the probability given, that's how you do that. You just multiply it by 2.
Okay. All right. Well, I'm gonna have to work on that one, but I'm willing to go on. I'm not getting something out.
What is it? What is coming up for you?
Well, to rephrase it, I'm putting 2 or -2 down in the T section.
Mm-hmm.
I'm changing the degrees of freedom to 8. And I'm shading both sides, both tails. And it's coming up 0.0805.
That's right. So you
You
round
just have to round up. Yep.
You get 0.08.
Okay. All right. Okay. trying to make it too complicated.
It's all good. Ever any more questions on that one?
No.
So the next problem is we have to make sure you do the quantitative inference procedures and go to paired sample t-test. And then you can just copy and paste them into the applet, and it'll give you the test statistic and also p-value. So
Sorry, what was that?
so for the next questions, it'll ask you the test statistic and p-value. So if you open the chapter 12 data A1
Yeah.
into your quantitative inference procedures, applet, whatever, that he gives you on the homework.
Okay.
And if you copy and paste those ones into that, it'll give you your answers for your t-test and also your p-value.
So I've got, for number 5, I've got 0.407. Is that correct?
Correct. That's what I got as well. And what did you get for your p-value?
I got 0.689.
That's what I got as well.
James, is that working for you?
I'm still trying to open up the applet thing.
Yeah, it's called quantitative. So if you go back to your homework thing, it'll say quantitative procedures.
You guys can move on. I'll catch up. My computer always gets slow when I get on to this Google Hangout thing.
Do you have a Mac?
Yep.
That's why.
I thought Mac was supposed to be superior at computing and graphics, all that other stuff.
That's why I have 1.5 terabytes of memory in mine. Nah.
My wife picked it, not me, so.
Oh, I see how that goes.
She's right behind me so she can hear me.
I can also email it to you if you need to.
It's okay. I'll find it eventually.
But yeah, when you need to find it, you just have to copy and paste it. Make sure it's a paired sample because there's 2 of them, and I'll say the differences, and then it'll just tell you on the bottom.
Okay.
You guys want to go on, or do you want to stay? It's up to you guys.
Whatever you guys want.
John, you good?
Yeah, I'm good with either. So,
All right,
yeah.
we shall go on.
Yeah, let's move on.
All right.
So what is the
So-
correct decision based on this evidence? Since our p-value is greater than the level of significance, I get these mixed up still, but would it fail to reject the null hypothesis?
Correct.
That's what I'm going with.
Yup, yup. And if we fail to reject, we have insufficient evidence. So the second one has to be right because we have insufficient evidence that the mean of the difference is greater than 0. It's not equal.
But why isn't it true that we have sufficient evidence?
Insufficient.
I know what you're saying, but why isn't it true to say that we have sufficient evidence?
That if we have sufficient evidence, that would be to reject the null hypothesis. Because it says in the first question, it says we fail to reject, so that's insufficient evidence. That's how I remember it.
Okay.
So if we fail, insufficient.
If you reject it, then you have sufficient.
Correct. That's how I remember it.
Okay.
So it's like you fail, you have insufficient, reject, sufficient, which is kind of like a double negative almost, but.
Okay, it says use the data file, chapter 12, data B1 to answer the next 8 questions. Okay. Perform a paired sample t-test in the SPSS. Be sure that the test does group 1 minus group 2. This data comes from
Sample
no
t-test.
something. The null hypothesis is equal to 0 and the alternate hypothesis does not equal 0. And the level of significance is equal to 0.01. N is greater. It's always greater.
Correct.
Since we learned that earlier, since n minus 1 is equal to d of f.
Yep.
And Blake, is there something in the future that affects that? Because, I mean, we've been taught that it's always 1 less than the n. Is there something changing in that in future situations?
It just all really depends on like what the sample mean is. Like they'll give it to you, so it's not something you have to like kind of figure out. The only times you have to figure out is if like the level of significance. It's pretty much the only thing. But this is kind of like a trick question. Like n will always be bigger, just like what he was saying. So it's kind of like they kind of throw you a curveball. So.
Okay. Well, I was just trying to figure out what the impact of it is and how important it is, because they reference it, but they don't ask us very much about it.
Like when you put into your applets, it'll ask you all the time, like, what is n? They'll usually give you n, like in the question itself.
Right.
You just have to make sure you have to go into it and put it in, because if not, you're going to get a totally different answer.
So the degree
Just like
of freedom determines kind of like the normal distribution. The higher it is, like above 30, you're going to get that normal distribution line, the normal bell curve. Lower you are, the smaller that area is going to be.
Mm-hmm.
Okay.
Yeah, anything over n is always normal, or it's a sufficient to have a normal, like what you said, a bell curve. Or I kind of see it as on the kebab. It's always going to be normal, so they won't have like crazy plots going all the way around. Always it'd be on the kebab or on the snake.
Okay. All right.
When we get into more stuff, we have to graph it and everything. This one's the same thing. You just have to put it inside of the applet as well. It'll go 1 minus the other one because it's a paired sample t-test. And what'd you guys get?
I got 0.001.
That's what I got as well.
Okay, I found the applet.
Good. Sweet.
Oh, what did you get for question 9 again? Sorry.
Yeah, it's all good.
So for question 9, we got n is greater than the degree of freedom because the degree of freedom will always be n minus 1.
And then because of the p-value is super, super small, 0.001, we reject the null.
That's what I got. Number 12, you decide to try another alternative hypothesis. This time, you use greater than 0, and you keep the same level of significance. Did the p-value increase or decrease? I've got it as decreasing.
So that is, well. And if it's decreasing on the question 13, we still reject the null because it's still super small, 0.05. It's less than 0.05, so still reject the null. And then if it's we reject it, we have sufficient evidence. So we have sufficient evidence that there is a mean difference between the two groups. So it's the third one.
That's what I've got.
And then question 15 says, as we have seen, the p-value depends on the alternate hypothesis. Which alternate hypothesis will give you the smallest p-value? That should be greater than. Shouldn't it give you the smallest p-value?
No, they don't give us enough information to determine that.
So that alone won't determine. I guess that alone won't determine.
Nope, because we have to know what's the difference between both of them. You can't just do one.
Okay.
Oh.
Because they're just saying which alternative hypothesis will give the smallest p-value. We don't know because what's the other one? Because maybe it could be greater, it could be less than, it could be not equal to, or it could be equal to. We don't know. They're just saying the HA, there is no HO, so we don't know.
Gotcha.
But isn't the HO always equal 0?
Not all the time, no. It can be, most of the time it is, but not all the time.
Okay.
It can be greater than, less than, or not equal to. It's going to be equal or not equal to. It's pretty much going to be one or the other. And plus, if it's always equal to, we can say that the HO could be smaller than the regular alternative hypothesis. So we just don't know. We don't have both of them.
Okay.
That was my logic behind it, and I got it right. So.
All right.
And then 16, I got wrong. I think it's 11.955, not 995.
What information is it using?
It's the one up on top, I believe. It's this one right here, the HO mu delta equals 0, and the alternative hypothesis HA mu delta not equals 0. And this level of significance is 0.01.
What did you say you got?
So I got it wrong, but I got 11.995, but I think it's 11.955.
Well, that's the mean. That's so the way I figure is you take the two confidence intervals, the 5.303, the 18.605. So you take 11, you take the X bar, or mean difference, or D bar, minus the lower, which is the 5.303. And then you take the upper, 18.607, minus the D bar, which should give you the plus or minus confidence interval, which is 6.652. At least that's what I did on one of.
I got that. That's the margin of error.
Oh, it's asking for point estimate. I was thinking of the.
Yeah, but yeah, you got the point. Yeah, that's exactly what I did to get the margin of error. 6.652.
Yeah, is that one of the questions?
Yeah, it's the next one.
That's the number. Yeah, that's the 17.
Yeah.
Gotcha.
I just don't know how to get the point estimate of. I don't know what I did wrong on that one. On 16.
Oh, yeah, it's this. So it's going to be M equals. No, that's margin of error again.
On the applet, the 11.955 is what you were saying?
Yeah.
Difference between the mean of the first variable and the second variable?
Yeah, that sounds like it's right. So it should be 11.955. We're just minusing the upper and lower, right? I think so.
Point.
Were we given an S value earlier? No.
I don't think so. We're just using the data from chapter 12 data Bravo 1, right?
Yeah.
So the population standard deviation is replaced with the point estimate, which is an S value, or in our case, the D sub S, the 15.003. Because so in chapter, I'm just guessing here, because it says in chapter 11 to construct a confidence interval when the population standard deviation is unknown, we replace the population standard deviation with its point estimate. The appropriate distribution is a T rather than a Z, so we replace T with Z. So the confidence interval when the standard deviation unknown is an equation. So instead of the standard deviation of the population, we're using S, the point estimate, which our data should be the difference in standard deviation difference between the two.
Yep. So yeah, that you would get 11.955.
Well, that's the mean. That'd be D bar. I mean, I'm down to try the 15.003 and see if that's right, but unless you know it's the mean. The what?
You said the difference. Isn't the difference 8.917?
You got to minus it if it's just the mean difference. So you have to get one mean, the other mean, and minus them. And the difference is, it should say on the bottom.
Yeah.
Are you saying for the standard deviation or the mean?
The point estimate is 15.003 is what I was saying.
Okay.
Put 11,955.
Yeah, and it could be definitely be the mean.
Yeah, I think so.
Standard error of the mean, yeah.
Okay.
So, yeah, I don't know which one it would be. But the lower bound was at 5.303
Yes.
and upper 18.607.
Yep. 13.05.
Do you want me to submit mine and see if it's the 15.003 or the 11.955? Since I still have 2 submits.
Yeah, I can do it real quick. I'm just going to make sure.
I can do the 11.
Yeah, it's 11.955.
Okay.
I submitted it.
I wonder what the standard deviation is then. Because it's technically not the standard deviation.
Yeah, did you get your lower bound 5.303
Yeah.
and then your upper bound 18.607?
Yeah.
Yeah, those are right. Yeah, it's 11.955 though. Weird. Type of test.
For the one that says 15.003.
Yeah.
How is it getting that? The difference. Oh, wait, never mind.
Eleven 11.9. Yep. I got the the differences of the means. Okay. I understand that now. Not just the means itself. Cool.
Hey, lots to study.
Yeah.
Yeah, true that, man. True that. Well, guys, you guys have any other questions? I gotta do some more project management homework. Yeah.
Have fun.
I think that's that.
You
Thanks
gotta
for your explanations.
try and. All right, guys. Well, I gotta get going. I gotta do some more forecasting, zoning, and crashing statistics. I gotta do. So sounds like fun, right?
All right. Have a good night, guys.
Good night.
All right. See you later, guys.
Tuesday.